And here we are again with Taco Tongue and Evil Eyebrow, part 2. This time we're going to answer the question, are these two skills independent of each other? So we're using the same data from yesterday, last time, part 1. And then what we're doing here is we're using a special word in probability. The word is given. Given that the person selected is a yes evil eyebrow, or given that the person selected is a no evil eyebrow. That means don't look at anybody else. Don't look outside of yes evil eyebrow or no evil eyebrow. And what that does is that changes the denominator that we're going to use. So 18, the subtotal, becomes 18, the denominator. And so 15 out of 18. And then 12, the subtotal, becomes 12, the denominator. Don't look outside of what is given. And you notice that these two probabilities are different. So apparently, your chance of being able to do what it says, and they actually say the same thing, really. They say, yes, Taco Tongue. Yes, Taco Tongue. So the ability to do the Taco Tongue depends on, or is connected to, is associated with the evil eyebrow. And how do I know that? Well, it made a difference. It made a difference from 83% to 42%. So look at this definition. Two events are independent if knowing whether or not one event has occurred does not change the probability that the other event will occur. Well, in this example, it did change the probability. Changed it quite a bit. So these are dependent. Evil eye, Taco Tongue have an association. They are dependent. And you think about it, if you're independent from your parents, that means that no matter what they say, no matter what they think, you can do whatever you want. But if they have some sort of way to stop you, then really you're dependent on them still. They say, I want to go out to eat by myself or with my friends tonight. And they say, no, you can't go. And you can't go, then you're dependent on them. But if you're living on your own, you have your own job, you say, Mom, I'm going out to eat with my friends. Mom says, I really wish you wouldn't. You say, well, you got a reason, Mom? She says, no, just a feeling. Well, you can go anyway if you want to go. You're independent. So they don't matter. If you're independent from someone, their wishes don't matter. Do you think that the United States asks Britain for the permission to do anything? No, 1776, they declared what? Independence, so that the United States doesn't have to depend on Britain. It doesn't matter what they think. So just ask yourself, does it matter? So are these events independent? It says no. People who can evil eyebrow are much more likely to be able to Taco Tongue. Now, stop for a second and consider this table. Now, this table is definitely fake data. It's cooked up data. And they made it so that, okay, just in general, Taco Tongue, 80%. Taco Tongue, yes, evil eye, 80%. Taco Tongue, no evil eye, 80%. So it doesn't matter. It doesn't matter if you can evil eyebrow or not. You're still getting the same answer, and therefore independent. Yes, independent. So didn't make a difference. Looking at our notes now, conditional probability is the probability of A given B. See that vertical slash is really a pipe character. You can find it on your keyboard. It's usually around the enter or return button, and you have to press shift to get to it. So what we're doing when we put that vertical slash, the condition that comes after it is basically the denominator, and it's what you look at in the table. You don't look outside of that. Even when you do the probability of A, that's the probability of A inside of B. That's why it says both right here. Both A and B. You're A and you're inside of B. That's the intersection. But then the denominator is just B in general. So there's B's in A and B's not in A. It's just all of B is the denominator. So when you form that fraction then, an independent event, it's not going to make any difference. You're going to get the same probability no matter what. Okay, so let me give you an example. Let's say that whether it rains or it doesn't rain, I bring an umbrella to school every day. Then the probability of me bringing an umbrella to school is 100%, whether it rains or it doesn't rain. That's a good example. And yes, I do. You may not know this, but yes, I have a little tiny umbrella I keep inside my bag, just big enough for my head to keep my head dry, but I bring an umbrella to school every single day. That way I don't have to remember to bring an umbrella. Okay, well, that is interesting where that led us to, isn't it? Two-way table to conditional probability. And of course, last time we had also talked about that formula for OR. So you put those things together, and that's basically what we do with categorical data and probability.